the human side. Are any of you interested in like research in medicine or medical school or anything like that? Okay, just want to make sure, because usually we have a whole bunch of people like that, but this is a completely group. Would you like to introduce yourself?
I live in Martinsburg, from South Carolina.
Where?
Elston, South Carolina.
Estill, okay, so near the coast. Okay.
I'm about to be a sophomore in college, and my major is landscape architecture.
Okay, awesome. All right, well, I will introduce myself. So my name is Sharetta Buford. I am from Chester, South Carolina, which I have no idea where that is. Between Rockfield, Columbia, York, Union, yeah, we in there. I am in my last year of my PhD program, but I'm a full-time employee here at Clemson in the College of Science. My interest is math as well. My science interest is math. And one cool thing about me is I won homecoming queen in high school and in college. After losing in middle school because they forgot to put my name on the ballot. All right.
All right. We're shooting for 10:30, right?
Yeah, because we do have to walk over to Hunter.
My name is Jim, and you can refer to me that way. So what I'm gonna do today is I'm gonna do a little bit of math that you're probably not used to. It's probably gonna look a little bit different than the math that you're used to taking in school. What are you all in?
Is it recording?
Yes. Okay. What are you all? What math are you all in?
Last one I took was pre-cal.
Pre-cal.
Last
Algebra 2, okay.
Yeah. Algebra 2.
Right, so you did a lot of things with or you probably did parabolas and lines and things like this, maybe the quadratic formula. This is going to look a little bit different, but it's math. It's a study of symmetry. But we're going to start counting. How many of you have ever played with one of these? Sure. How many of you can solve one? How do you know how to solve it?
I learned some like algorithms for like certain placements.
Okay, got you. I'm going to show you how to do this or how to develop a way to do it and make up your own moves. The first time I ever solved one of these things, it was actually with a pencil and piece of paper. And I want to show you how to do this, and so you can create your own way to do it. The first thing is, why do we need to solve this? Does anybody know how many combinations there are on the cube?
A lot.
A lot. Actually, that's not even being facetious. There's a lot. Let me think how we would count this, right? Have any of you ever cheated on the Rubik's Cube, taking it apart? Oh, you pop the corners out. That's the best way.
I would use an app to try to figure out like.
Yeah. So don't take the stickers off. Bad idea. It doesn't work very well. But if you take it apart, the Rubik's Cube is a very interesting piece of engineering. When you pull it apart, it'll look like this, a little skeleton here. And then this way. And so if you notice the center pieces on the cube, the one with only one color on them like this, they're always opposite to each other, right? The blue and the green, they're always opposite. And in fact, there's no piece on the cube that has a blue and green, right? Now, if you forget about the centers and think about the pieces that you can take out, there are basically two kinds. Anybody want to classify them? How can you tell what two kinds there are? If you were to pull this apart, take it apart with a screwdriver, they're basically centers, and then there's two other kinds of cubes. Can anybody tell me? Okay, so there's the corners, and then there's, I'll call these the sides or the edges. What distinguishes these two? That's right. The corners have 3 colors, and the edges have 2. Correct. So let me ask you this: so how many combinations are there on the cube? First question: how many corner pieces are there? Agreed. There's 8, right? 4 along the top, 4 along the bottom. Okay. And how many side pieces are there? Oh, you're quick. That's right. There's 12, right? 4 along the top, 4 along the bottom, and then sort of a bevel around the middle. Everybody okay with that? Yeah. So let's imagine for a moment that you have taken a Rubik's Cube and pulled it apart. And so now you've got pieces all over the place. You've got the 12 side pieces and the corner pieces. But all of a sudden, in your attempt to put it back together, you are stricken blind, right? So you don't know how to put it back. You can only put it back by finger, right? Now, there's no way you're going to ever put a side piece in that position or a corner piece in that one. Everybody agree with that? So, how many ways are there to put the corner pieces back? Well, think of it this way. How many corner pieces do you have?
8.
Okay, and how many places can you put that? 8. That's right. So basically you have 8 blank spaces to fill in, right? How many choices are there?
8.
Put the first one. Okay. So now you put one of the corner blocks in, right? How many choices are there to put in the next piece? 7.
No, that'll be. That's where all the 8 is.
And anybody know a shorter way to write this?
That's where.
Yes, this is 8 factorial. Right? Everybody's seen that notation before. Can you follow the pattern here with sides? How many ways are there to put sides back?
12.
Right, that's right. So there's 12 side places and then 12 side pieces to put in 12, 11, 10, 9, 12 factorial. Everybody agree? So there's 8 factorial ways to put the corners back. There's 12 factorial ways to put the sides back, right? So there shouldn't be that many ways to put it all back. Or is there? There's actually more ways than this. Can anybody tell what we missed in our count?
Oh, what do you put it on one side, like the side?
That's right. If you're to take this apart, right? Imagine just putting one side piece back in, right? How many ways? So everybody agrees, I guess, that the blue red goes there, but how many ways can you put that side piece in there? 2. So every side piece can be put in 2 ways. Color up, color down, right? So there's 2 to the 12th ways to do that. How many ways can you put the corner piece in? There's 3, right? For example, this one, let's be patriotic here, red, white, and blue. You can put red up, white up, or blue up, right? So there's 3 ways to put those in. 3. This is the number of ways to reassemble a Rubik's Cube if you are blind. I would not recommend doing this because that's 12 times too many of the number of combinations. So in other words, if you assemble a Rubik's Cube in a random configuration, right, in just some random configuration, there's only 1 in 12 chance that you can solve it without pulling it apart again. The actual combinations, and there's mathematical reasons why this is 12 times too many, is actually 11 factorial times 8 factorial times 2 to the 12 times 3 to the 8. And this is about 4.3 times 10 to the 19th. Now, this, I had a box with some of these Rubik's Cubes when I first bought them for high school math kind of camp. And the boxes they came in and said billions of combinations, only one solution. You will never see such understated advertisement. This number is actually huge. How many of you have had a chemistry class? This number is smaller than that. Y'all remember Avogadro's number, 6.02 times 10 to the 23rd, or I guess it is. This number is much smaller than that, but it is still a very, very, very large number. So just to give you some perspective, we will assume that there are 330 million people in the United States of America. put them all in a line, and give them all Rubik's Cube and say, go. And when you say go, each person in that line starts scrambling the cube. All 330 million of them get a different combination every second, right? And we've got a big computer that just collects all the configurations. Every one of those 330 million people are getting a new combination on the cube every second. Nobody's repeating what anybody else did for 40 years. And at the end of that time, you will have amassed about 0.8% of the number of combinations on the cube. Right? So this is a very, very big number. You're not going to guess this, right? You're going to have to use some intuition or some mathematics or something. And I'm going to show you how to do this kind of from first principles. Well, let me give you kind of another motivating thing here. Suppose I take a solve cube, okay? And suppose I do something to it. Suppose I scramble this somehow and write down what my scramble is. Now suppose that I do that scramble over and over. Will it ever come back to being solved? Well, let's do what the lesser scientists do and do an experiment, all right? Here's my move. Let's see if it comes back, shall we? 1, 2, 3, 4. Ding, 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 ding. Well, that wasn't very exciting, right? I mean, no surprise. What if I make it just a little bit more complicated? What if that's my move? And do that 3 times, 4 times. Now my question is, what's going to happen as I go down the road? Am I ever going to get back again?
Yes.
Okay, I hear a pretty strong yes out there. How many of you think that I'm going to get back? How many of you think that I'm not going to? That I'm kind of. I mean, if y'all see the cross that happens every so often, like now. Every so often I get a cross, but I'm kind of worried that I might be in an eddy, right? Sort of like circling around the drain or something like that. How many of you think that I'm stuck and it's never going to come back? Yeah, it's hard to tell, isn't it? Anybody want to justify their answer?
Oh,
yeah.
So you said people who say that they're not going to come back. I don't think it's not. Well, eventually you will because there's only so many combinations. So eventually, I mean, it's guaranteed that you'll make it back. It's not like you're creating more possibilities just from trying.
Of course, it's strong with this one. So his argument is that there's only finitely many combinations. So eventually you've got to come back. But my question is, what if I've already repeated something? But then, looks like and actually this holds true for any combination on the cube, right? If you start with a solved cube, do anything to it, write it down, and repeat it over and over again, it'll eventually come back. And that's one of the symmetry conditions on the cube. And actually, you are at the heart of why that's true, because there's only finitely many combinations. Now, what I want to do is I want to do this move here, and I want to analyze it. I want to show you how to kind of map the cube. The first thing that I've done here is I've drawn a map for you all. And I'm going to use this one a little bit later. This is for the orientations, but this is kind of geographically. I'm going to call these A, B, C, D, E, F, for some reason. Actually, I don't want to do it that way. I want to do it the other way. E, F, G, H. And I'm going to number the edge pieces 1, 2, 3, 4, 5, 6, 7, 8 around the belt, 9, 10, 11's on the back, and 12 is over here on the side. Okay. And I'm going to have to teach you a little bit of notation first. And this is unfortunate. I'm sorry we have to do it this way, but we're in keeping with what is used in cube terminology. So I'm going to define some moves. D for down. Well, actually, let me start simply. I'm going to start with F. the front. Okay, when I turn the front of this cube clockwise, I'm doing two things. I am messing with the corners and I'm messing with the edges, right? But only for a piece. So my front move here, and this is the notation I'm going to use. If I turn this front piece clockwise, like this, where does A go? A goes to, I turn clockwise, that is clockwise, and then clockwise it goes to B.
I'm looking.
Where does B go? To C, and C goes to B. This notation means A goes to B, B goes to C, C goes to D, and then we're at the end of the line, you flip back to the beginning. D goes back to A. Everybody okay with that? Now it also does something to the edge pieces, right? Where does one go? Yeah, it goes to 5, I agree. And 5 goes to? Which goes to? And 8 goes back to 1. Everybody okay with that? And let's see, I'm actually only going to use 3. I'm going to do R for right, clockwise. Okay, let me try to think about this. If I turn the right side clockwise, from this perspective, it's going this way. So where does block B go?
I was still doing it if the first time was turned.
I'm imagining I'm turning this block right here.
Okay, so first side is like in the original position or A still like B.
Yeah, it's just in the original position, and now I'm going to turn this side here. So where's B going to go? Agree. B flips to F. Agree. How about F? Where does it go? Turn it like this.
No, this is G.
Goes to G. And G goes to C. And C back to B. Agree? How about the side pieces? Or the edge pieces here? Let's start at 2. 2 goes to
6.
which goes to 9.
Oh wait, okay, I get it. I see what you're
Everybody cool? And finally, let me do D for down. And I'll kind of explain this here. Imagine for clockwise and counterclockwise, imagine that I've slid up under this and I'll look at it from under it. So if I turn it clockwise, it goes like this. The bottom goes like this. So where does C go? If it goes clockwise, look. C goes to G. So imagine sliding under it, looking up above clockwise. G goes to the, H, the backside when you can't see. H goes to D, and D goes back to C, right? And I've set the bottom, the down up, so 9, 10, 11, 12. Everybody okay with that?
Yeah.
Now, I call these moves front, F, R, right, and D down. And I apologize that F and D double up here. Hopefully it'll be clear from the context. If I put a prime there, I'm doing it counterclockwise. Now, y'all remember that scramble I did, and I had to do it a bunch of times to come back. I did that. So that is, from my perspective, if this is the front, this is right, counterclockwise, down, counterclockwise. So let's practice that. That's the move. Oops. Write them down, didn't I? So the move I did was right prime, down prime. Okay with that? I want to analyze what happens to this. Now, this is kind of an unfortunate thing here, but and I'll give you an explanation why we do this. We actually do this in reverse. We do it like function composition. So let me take you back to the days of plugging in functions. If I said, okay, let x be 2 and figure out what this number is in your calculator, what's the first thing that you do? Take the 2 and square it and then add 1, right? Everybody okay with that? Yeah. Then you do the cosine, then you take the square root of the whole shebang, right? And I hope that turns out to be positive so you can get the square root, but for the same reason, we do this in reverse order, right? Because what we're doing, when you see this written up, if you look at if you looked on the internet for a cheap solution or something like that, the moves are written in English in the order you do it, from left to right. Figuring out what the blocks do is done like function composition. So when I made this turn, the first thing I did was right backwards. Okay, let's look back here. Here's right. This is right clockwise. What do you suppose right counterclockwise is?
CG.
Just run it in reverse. Everybody okay with that? So that should be what? CGFB? And now we got to run down in reverse. So that's DHGC. Everybody okay with that? Now let's do the same while I'm thinking about it. Let's do it for our sides as well. Right backwards, that's 5, 10, 6, 2. And down backwards is 12, 11, 10, 9. Now, I want to see what this turns out to be. And let me show you how to multiply these things. Okay, I'm going to start with alphabetically the first thing I see, which in this case is B. Where does B go? To C. And then pick up where you left off. Then C goes on to D. Right? So where does B go? In the first step, it takes the train to C. Second step, it takes the train back to D. Everybody okay? Let's do it again. Where does D go? Nowhere. And then to H. Everybody okay with that? Where does H go? Nowhere. And then to G. Where does G go? To F. And then nowhere. So it ends up at F. Where does F go? To B. And then nowhere. So it goes back. So have we got all the letters covered? Is there anything missing? Are there any letters up here that we haven't covered?
C.
C. Where did C better go? C goes to G and back to C. So C stays where it is.
Okay.
Yeah. Okay, how about this? Let's practice this here. I guess the smallest number I've got in there is 2. Where does 2 go? To 5 and then nowhere. Where does 5 go? And then? Right. It's a 2-step. It goes to 10 and then on to 9 and it's done. Where does 9 go? To 12, goes nowhere, and then to 12. 12 goes to 11. 11 goes to 10 goes to 6 goes to. Now it looks like in this case, I've already picked up all the numbers, right? I've got 9, 11, 12, and then what's left? 5, 2, 6, I've got them, right? If you've done this right, you should have no repetitions and you should use up all your numbers. And here I used up C as well, my opinion. Now, let's kind of take apart what's going on here. What this says is you do this dance here. And notice, by the way, here is block C. It's the one that is white and green and orange. What happens when I do right prime, down prime? There it is, back into place. Everybody agree with that? And these other things do a dance around. Let me ask you this. Think about what's happening to the corners and to the sides as separate entities. How many times must I do this little dance before the sides come back to being fixed? Or I'm sorry, the corners come back to being fixed. Anybody want to guess? Well, think about what happens. In the first dance, B goes to D. If you do the dance again, it'll go on to H, do it again to G, then to F, and then back to B. 5 times. Everybody agree with that? And what's true for B is true for the rest. C just dances right there, never leaves. But D, step 1, step 2, step 3, step 4, step 5, back to D. Everybody okay with it? So it'll take every 5 times, it should fix the corners. How about the sides? You want to take a stab at that? Seven. So let's see, shall we? So, by the way, if every 5 times the corners are fixed, and every 7 times the sides fixed, how many times is it going to 35? 35 times it's fixed. Okay, let's count. 1, 2, 3, 4, 5, 6, 7. Notice the sides are fixed. Across. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 3, 4, 5, 6, 7, 28, 29, 30, 31, 32, 33, 34, 35, and we have solved. Oh, but it is solved, right? Geographically. What piece belongs? Would everybody agree the sides are all correct? Sides are all correct. What piece belongs right here? Red, yellow, green, and that's what's there. What belongs here? Yellow, blue, orange, and that's what's there. This cube is geographically solved. So in doing this dance of 35 steps, it's basically like God took these pieces right here and turned them 120 degrees. Everybody agree with that? How many times do we have to do this move?
2 more times is 360.
That is correct. So if we do that 35 again, it'll be screwed again. If we do it at 35 again, it'll be back. So how many times did I do my little dance?
I did it 3 times.
It'd be 35 times 3, which is 105. That's exactly right. Everybody okay with it?
I'm just happy y'all were following.
This also illustrates something else, though, because this is a cube that is solved geographically, but it's not pleasing to the eye in the sense that the pieces are screwed out of place. So we're going to need to think about something else. We're going to need to think about what we call orientation. And so I am going to up the voltage here on let me give you a couple moves here. I'm not going to talk about orientation quite yet. I'm going to talk about it in a minute, but I'm going to give us kind of a practice move on this kind of thing. So let me give you the following move. I guess I can erase this. And like I said, I'm not going to talk about orientations yet. I'm going to talk about a strategy here. And you can come up with your own. So this move is D prime, I think it's R prime, D, R, D, F, E prime, F prime. Okay. Now, I'm going to, so this move will actually, I'm going to show you how this move's going to help us a little bit here. How many of you do you think could get one side of the cube? And by one side, I mean, here we go. Well, one side, I mean, you can get it this far with one color and correct around it. Get it that far?
I got it earlier.
Well, if you play around with it, you can practice. It's not too difficult to do because you've got a lot of freedom and just getting one side. And it might take a little practice, but if you spent like, you know, an afternoon kind of mucking around with it, you could probably get it this far. But it's hard to move on from this, right? Because here's your accomplishment, right? And now it's really hard to move anything else on the cube without screwing up what you've already done. That's kind of the difficult part, right? That's one of the problems. Here's another problem on the cube. Another problem on the cube is order matters. See this move here? So this and this, that's what it looks like. If I do it the other way, that's what it is. And that's one of the reasons it's very hard to solve the cube. So how do we get past this though, if we've got one side? This is one step that will help you if you decide to do it this way. So let's analyze this. Let's see, this is an 8-stepper. So 2, 3, 4, 5, 6, 7, 8. I'm going to do the corners and then the edges. And this will be good practice for us to compute and see if we can figure this out. Okay, this should be front prime, down prime, front, down, right, down, right prime. Now, this may look really horrible, but it's not so bad really because there's only a couple of things we have to fill in. Okay, let's go back to our key here. The front, that's A, B, C, D. So A, B, C, D. And this should be in reverse. D, C, B, A. Okay, so let's fill in the right. Right is B, F, G, C. And right prime should be C, G, F, D. And finally, everything else is down. C, G, H, D. C, G, H, D. And now in reverse. D, H, G, C. And reverse. D, H, G, C. Okay. Let's figure this out. And hopefully in figuring this out, we'll figure out why this might actually plus. Let's go through this. What happens to A? Where does A go? Well, let's get started with this. No A, no A, no A, no A, no A. Ah, A goes to B. No B. And back to A. How about them? It just left alone, right? How about B? No B. Okay, B goes to C, to G, to C, to G, to C, to, after all that dance, B is back where it started. How about C? See if you guys can figure out where C is.
C.
Looks like. Okay. How about D? It goes to, ends up at. How about that? Okay, pick up where you left off. How about H? Where's H in there? I agree.
Yeah.
Let's check. H goes to G, to F, to G, to H, to G. How about G? Yes, very good. It goes to, this one does kind of a funny thing, so let's check that. It goes to C, to G, to H, to D, to A, to D. Correct. There's no E in there at all, so just to record it, E just is left alone. How about F? Yeah, it does. It stays where it is. F goes to B, and then back to F, and then it's done. Okay, everybody okay with that so far? Okay, let's see what happens to the side pieces. Okay, let me do this again. My front is 1598. So in reverse, this is 8951. Let's see, my down is, I'll let down, it's 9, 10, 11, 12. 9, 10, 11, 12. And then 12, 11, 10, and 9 for the backwards. 12, 11, 10, 9. And finally, the right is 2, 6, 10, 5. 2, 6. And this is 5, 10, 6. Okay, so let's go through this. Where does 1 go? Go to 5 and then back into that short trip. 2. I agree.
Yes.
3. Well, there's no 3 at all, is there? And while I'm on the subject, there's no 4 either. How about 5? 5 is the first one that does something interesting. You guys get too quick for me. Yeah, 11 it is. How about 11? Mm-hmm. Mm-hmm. 10 goes to. Let's see, where does 10 go? I'll lose track of that one myself. 10 goes to 9. to 10 to 5, the 9 to 12. I agree. How about 12? Very good. Are y'all getting this on?
Yes.
How about 9? Okay, good. So it completes the cycle back here. Now let's see, what am I missing? It looks like I'm missing 6. What happens to 6? Yeah, 6 goes to 2, and then back to 6 and it's done. There's no 7 there. So I guess the only number left is 8. And since I've used up all the rest of them, where does 8 have to go? It has to go to 8, right? I mean, look, all of these have to end up in different places, right? I mean, if I scramble this and I get 2 sides right there, I got problems, right? So certainly 8 better go to 8, but this is a good gut check. So 8 goes to 1 and back to 8. Good. Now, let me ask y'all a question at this juncture, and that is, let's suppose that I've gotten the cube this far, right? So I've got one side all pristine and everything else is kind of screwed up. Can somebody explain why this is going to help or how it could potentially help?
Like it's like the thing we just said earlier, but it's like more expanded.
Well, so let me ask you this. If you look at the map of the cube, I've got the top fixed, right? So I've got the top, I'm happy with the top, don't want to mess up the top. What does this do to the 4 corners on the top? A, B, E, and F. What happens to them?
They stay there.
They stay there.
So you got like a guarantee.
Right. What happens to the 4 numbers on the top? 1, 2, 3, 4.
They stay there.
They stay there. So this thing does not mess with what I've done. Now, I didn't pay attention to the orientations yet, but it turns out that this move doesn't interfere with them. And this is why it might help. What does the move actually do? Well, it takes the 4 bottom pieces, the corners, the 4 bottom corners, and it gives them a little dance, right? This one will go to the back side, H goes to G here, and G comes all the way across to D, right? And this is the important thing. These 4 are on the bottom. The 5 goes to 11. So, and actually 9 goes to 5. So what happens in this move is this block moves up a level. This one is demoted down to the back side in 11, and the rest just dance on the bottom. All right, so how does this help? Let's see if I can get into a helping situation. Here's a, if you take a look at the cube right here, I need this green yellow piece to go right up here into this position, right? That is 9 goes to 5. That's what this move should do. Down prime, down, right. The rest of it, and of course, always, here, let me try that. So I need this to go up here. Here's the move down. There we go. And there it is. And notice everything else is left alone. So, for example, I need this to slide up the other way. I actually do the mirror image of this move. So imagine it moves around and sort of reflected about a mirror. Here. Here we go. So what we have here is yellow, blue, it needs to come up here. And if I just do this move down prime, right prime, down, et cetera, that's what we get. And so finally, one more time on this move. And now I've got 2 of those just for doing this. And like I said, it's mirror image. Okay. So using this move and its mirror image, and we can discuss that later, you can basically get 2 rows. But now the stakes are higher because now I want to come up with something that leaves not only the top alone, but now both rows. And if that's what's on the menu, this isn't going to work anymore because this move took 9 to 5 and 5 down to 11, right? So it actually messes with the second row. Right? Everybody okay with that? So I'm going to give you one more move here. But now I've got to up the voltage a little bit because I need to talk about orientations. Let me give you one more move that might be of use. Last move that I want us to analyze, and I'm going to show you how to talk about orientations that you can do for others too. This one's 9 instead of 8, RD, R, F prime, R prime, F, D. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we go. Okay, here's the obnoxious part where I've got to write it in reverse here. I've got 9 of these things. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1. Okay, so this is down prime, front, right prime, front prime, right, down, right, down prime. Okay. Actually, I think for this one, I'm going to do the sides first because it's easier to deal with their orientations. Okay, so I am going to add to this. I'm going to add to my diagram moves their orientations. Let's think back to turning this front piece clockwise, right? What does it do? Well, 1 goes to 5, 5 goes to 9, 9 goes to 8, and 8 goes back to 1. Now, what I'm going to do is I'm going to record the orientation. And let me tell you, I made up this orientation here. So notice that all the edge pieces, the ones with 2 colors, have a 0 and 1 on them, right? A different 0 and different 1. And the ones that are corner pieces have 3 colors on them. And basically this corresponds to whether which color is up, right? Now, by the way, you can orient this any way you want. I happen to orient this way because it's going to make things a little bit easier. But as long as you got 0s and 1s and that sort of thing. Notice that when you add up the orientations here, I'll get to that in a moment. -1, I guess. So when I turn this block here, 1 to 5, 5 to 9, 9 to 8, let me tell you how the orientations go. What you do is you start with whichever block is a 0 and read where the 0 goes. So when 1 goes to 5, the 0 block ends up at the 1 space. That's a 1 orientation. Everybody okay with that? If you start here, 5 to 9, the 0 ends up at the 1. So that's a 1. Everybody agree with that? If you do 9 to 8, the 0's on the bottom and it ends up over here, which is a 1. So that's a 1. And finally, when 8 goes to 1, your 0 ends up at 1. Everybody see how that works? What happens when you add up all the orientations? A multiple of 2. It's a multiple of 2. Yes, 4. Let's see what happens on the right. And you'll see why I did the orientations this way. When I turn the right clockwise, 2 goes to 6, 6 goes to 10, 10 goes to 5, 5 goes to 2. Let's see, when 2 goes to 6, can you all tell where the 0 goes? So here's the 2 block here, it folds over here, and it goes to, the 0 goes to 0. That is correct. When the 6 block goes to 10, the 0's on the back side, and it goes to the 0 on the underside. 10 goes to 5, the 0 goes to the 0. Convenient. And how about down? Look at the way I oriented the down. All the down blocks are 0. So when you turn the down, it's going to be 0 orientations across the board. Everybody okay with that? Now, how do you do the corners? You do it the same way, only now you've got more numbers to choose from. So when you do the front clockwise, again, ask yourself where 0 goes. Okay, let's look at A block goes to B block. 0 goes where? To 1. When you turn the B block to C block, the 0 ends up at A. I think it is up at the 2.
Yes.
2. When C goes to D, the 0's on the bottom here. Where does it end up on the D block? At 1, correct? And when D goes to A, 0's on the bottom, it ends up at 2, correct? What happens when you add up the orientations here? 6, a multiple of 2, right? Let's check out these other ones. Right. How does the right work? B goes to F. Let's see, when B goes to F, the 0 ends up at 1. When F goes to G, 0 ends up at 2. When G goes to C, the 0 ends up at 1. And this better be a 2 for it to add up right, and it is. Everybody okay with that? And once again, the down is useful because the down is all 0s. Because I've got all 0s on top. Everybody okay with that? Now let's work through this. All right, so let's fill in the sides first here. Yeah, I'll do the sides first. Front is 1598. And that's 1, 1, 1, 1. And 8, 9, 5, 1 is 1, 1, 1, 1. Let's look at the right, which is 2, 6, 10, 5. And right prime is 5, 10, 6, 2. And finally, down is 9, 10, 11, 12. And down prime is 12, 11, 10, 9, 9, 10, 11, 12, 12, 11, 10, 9. Notice that I did not write the orientations for the downs and the rights because they're all 0 orientation, and orientation doesn't change that. Everybody okay with that? So, right, so it's just those F's that can change the orientation. So let's see what happens here. Let me go through a couple of them anyway. 1 goes to 8 with an orientation 1. 8 goes back to 1, so now it's up to 2, which is 0, right? Because every multiple of 2 flips you back to where you were, right? Flip, flip. So 1 is left alone. How about 2? 2 goes to 5, 2 to 6. I'm going to change to 2, and there we go. There was never an orientation change on that. How about 3? I don't think there's a 3, so that's a clean slate. I don't think there's a 4 either. Let's see what happens to 5. 5 goes to 10, to 9, to 10. Let's see, I'm going to check it. 5 goes to 10, to 9, to 10, to 5, to 1 with a 1 orientation, back to 5. So it's left alone. It's switched and switched back. How about 6? 2 to 6 to 10. To 7. Exactly. 8. No, 8, no, 8, no, 8, no, 8, no. 8 goes to 9, orientation 1. 9 goes to 8, orientation 1. And so 8's left alone. Now it gets a little bit more interesting. By the way, check it out. Here's what we have so far. 1, 2, 3, 4, 5, 6, 7, 8, all left alone in their same orientation. So I can do this move with impunity without messing up any of the top 2 rows of signs. How about 9? Where does it go? It goes to 12, to 9, 5, to 5. Okay, good. Okay, it goes 9 with a 1 orientation. How about that? Right, we ended up at 9, didn't we? Yes. Okay, how about 10? Right, okay, so 10's just left alone. How about 11? Yeah, you're right. You're fast. That's right. 11 goes to 12 with a 1 orientation. And by the way, before we do the computation, you want to make a prediction on what happens? There's only 1 move. Where does 12 have to go geographically?
Has to go to 11.
It has to go to 11. And I've already had my orientations add up to a multiple 2, so this has got to be a 0. I bet. Let's see what happens. 12 goes to 11, to 12, to 11. So it's a 0 orientation back.
Oh.
And notice the total orientation move adds up to a multiple of 2. let's try this bit on the corners. I think I can fill in the blanks pretty quick. Front is ABCD with orientation of 1, 2, 1, 2. Anybody want to guess how the orientation is going to work in reverse? C to D is 1, so D to C better be a 2. Just got to cancel it out. And you can check that. If D goes to C, the bottom 0 goes to the 2 here.
Yeah, it's C to D 0 goes to
Yeah.
1.
Right, okay with that?
It's like, dang, it's not make sense. It makes sense.
So are y'all okay with it?
Yes.
Okay, so let's do right. BFGC. BFGC. I'll come back in with the orientations. And I think it starts with a 1. 1, 2, 1, 2. 1, 2, 1, 2. Okay. Oh, and I got to do right prime, don't I? Which is CGFB. And right prime all the way here at the end, CGFB. And just like it should run in the opposite, so it should go 2, 1, 2, 1. These will be a little bit harder to keep track of, but it won't be so bad. 1, 1. And finally, I guess we have down, which is CGHD. And down prime is DHGC. And just like before, I'll leave the orientations out because those moves have 0 orientation. Everybody okay with it? Okay, there's only 8 to do. And so let's kind of run this here. Let's see where A goes. A goes. Okay. No. A goes to D, orientation 1. And D goes back to A. Now we're up to 3, which is 0, right? Because every multiple of 3 for the corners is 0. How about B? B goes to, this is going to take a while. B goes to C, to D, to C, to B. So now we're up at 3, so we're back to 0. Then on to A, and then to B, so we're back to 0. After the big fat dance, this is again the 0 orientation. Right? How about C? G. Okay, so we're up to 4, which is 1, 2. Okay, we're up to 4, which is 1. Up to 3, which is 0. How about D? And then C on to, which is 4, back to 1. You just, with a 1, right? Okay, there's no E. E wasn't involved in this fiasco at all. F, how about F? Yeah. Okay, last one to check is G. It better go to itself. We'll see what happens to it. Oh, wait a minute. Before we do it, you want to guess? It has to go back to itself. You want to predict the orientation? There you go. That's right. Excellent. Let's check it though. It's always good to check old Jim. G goes to F with a 1. And then on to G, we're up to 3, which is 0. Then on to H. And I missed something. I clearly missed something. See, G goes to F with a 1. So that's back to 0. G goes to H. And H goes to G. Yeah, something else. Oh, I know. Do you know what my mistake was? In principle, you're right, but I forgot that there's another letter in the alphabet. This is a 0, but what H has to be too. There we go. Yeah, your argument was correct, but I haven't run out of letters yet. Let's check H. H goes to G. G goes to C. C goes to G. G goes to C, so we're up to 2. C goes to B, so we're back to 0. B goes to C, we're up to 1. C goes to D, we're up to 2. D goes to H, and there's your 2. Now, let me draw you a map of what this looks like at the end of the day. What this does, so imagine that I take the Rubik's Cube and tip it over. So I'm looking at the bottom. Okay, so in my diagram here, just to make clear, this is block C, block D, block H, block G. And this is 9, 10, 11, and 12. Right, so I've tipped it up and I'm kind of looking at it. Let's see what this actually physically did. Right, because notice, again, A, B, E, and F are left alone. So the top row of corners and the top 2 rows of sides are left alone. What this effectively does is this swaps C and D. Like this. And when C moves to D, its orientation is 0. And when D moves to C block, its orientation is +1. Right? And everything else is left alone except for H, which has orientation +2. Which basically what this means is this is screwed counterclockwise and this is clockwise. What happens on the sides? On the side pieces, what it's done is 9 has orientation +1. So I'll write a plus. That just means it changes. And 11 and 12 are swapped. The 11 going to 12 changes the orientation, and the 12 goes to 11, leaves alone. And that's enough. Just that, solve the cube. However, you can take this and come up with all kinds of shortcuts. Let me show you why this is true. Let's look at the bottom here, and I'll show you. I will solve this cube before the end of your session today. Let's see. So let me try to fix this a little bit. So here I have blue, blue, but they're in the wrong place. Agree? Notice but this move swaps these two. And I don't care anything about geography yet. I just want to get these two blues in the right place. So I do this move. And notice it's left everything alone and now correct geographically. Right? These two are already correct geographically, so I don't have to worry. Now I'm going to try to fix the sides. Notice this side is in the right place. This needs to come over here. This needs to move here. And I also don't want to mess up the fact that all my corners are correct now. But notice, if I do any of these moves in tandem, if I do this twice, it'll fix the corners, right? So actually what I'm going to do is I'm going to do this move and I'm going to do its mirror image, which flips these two. So to get this over here, here's the move. Now my corners are screwed up and I do the mirror image and it unscrews the corners, but it should have moved all the pieces into the correct hole. Now, what I want to do now is I want to fix these two sides because they're not oriented correctly. Right? These two, they're good to go. These two, back. Right? Notice, if I do this twice, my corners will be correct. And what happens if I do this twice? It'll change it and change it back. So this will be good. It'll flip these, changing one, and then it'll flip them, changing the same one. So if I do this twice, it should flip these, and in the process, fix them both. So let's do it twice. Once, twice. And there you go. All you've got to do now is fix this. Now notice, and this is why my move's not really super efficient. But if I do this 4 times, these will be geographically correct. Switch, 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 right? And what will happen when I do this? And this will turn counterclockwise 4 times, right? So this will be a +8, which is actually another +2. So 2, 2, 2. So if I do this actually 4 times, it will essentially go counterclockwise on everything. So I'm going to turn everything counterclockwise here. Let's see, I want which one? I want you to turn counterclockwise. So what I'm going to do is I'm going to turn this one. I'm going to turn 3 of them counterclockwise. This one. Yeah, this needs to be one. There we go. I'm going to turn this one, and this one counterclockwise. So now I'll have 3 messed up. That's going to be okay.
How does that make it all +2? Make them all like 2.
Okay, I'll go through that. Let me check. I wouldn't rule out me making a mistake here. Imagine what you do here. Okay, one moves counterclockwise, 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 counterclockwise. You're back. And then one more counterclockwise is counterclockwise. And this one up here, yeah, let me try to keep track of this. So turn you clockwise, you're still clockwise. Turn you clockwise again, you're still clockwise. So your two clockwise, which is one counterclockwise. All right. And that's exactly what I've done here. So I've turned all of these this way. Now I've got to turn these clockwise to fix them. So I do the mirror image of this move, or I can just do counterclockwise until I'm blue in the face. But it's quicker for me to do this. And 9, 8, 7, 6, 5, 4, 3, 2, 1.
That's crazy. Oh my gosh.
Who's gonna do this when y'all get back, like, to school?
Oh,
the point is you can actually use this technique to come up with all kinds of shorts.
Try to do like those.
Everybody see how that works? And that is part of the power of mathematics right there. Because we use math. What's that?
I try to do like 2 colors on top of it. See, yeah.
Well, let's see here. So when I get here, I would just apply that first one because it's easy to do this. Get the side right. Notice this side it put in the wrong way. So I'm kind of primitive, so I just take it out and then put it back. So here's the move that puts it back. And I'm almost to 2 rows there. So now I got 2 rows. Now all I've got to do is this one, and I can use this over and over and over again to get any configuration. So the first thing I need to do is get the corners correct. So these 2 corners are correct, and these 2 need to be changed. So I just do the move once. Now I've got the corners geographically correct. And I am such a lucky fellow because the sides turned out to be that way as well. These sides need to be fixed, so I do the move twice. And that makes sure that I haven't messed up my corners, and it flips those 2 side pieces. So now I'm here. And from here, let's see, I want to turn you counterclockwise. So yeah, like I'm not going to win in speed cubing rate with this. I've gotten fast enough in it to where I can consistently get it under 2 minutes, usually about 1.5 minutes from scratch. But for me to be less than 1 minute, I have to get lucky. Just like I got lucky on those side pieces because they came together for me unexpectedly.
We will have to go because we got a little walk across campus.
Oh yeah. So if you all just if you are curious about anything, just drop me an email. And I hope you found this interesting. And that's some of the power of my.
Thank you so much.
You guys.
Hopefully that was intriguing. It was a lot, right? Look, you got people taking pictures of it.
Oh yeah.
We do have to take a little hike across campus. Does anyone have to use the restroom? Oh, good. Okay, just me. That's fine. So we'll walk.